We are given two different points P and Q, and our duty is to find the distance between these 2 points, which are in xy plane. So the coordinates of point P are x1 comma y1, and the coordinates of point Q are x2 comma y2. Now if you carefully draw a perpendiculars from these 2 points to y-axis, so let me drop the perpendiculars from Q. So I'm dropping a perpendicular from Q towards y-axis. So this distance will be y2. When you drop another perpendicular from P to y-axis, this distance will be y1. So it clearly shows that this distance, which is a perpendicular distance, has a length of y2 minus y1. Similarly, when you drop a perpendicular from point P and Q to x-axis, you can observe that. So this perpendicular, so this is the x distance. You can understand this as x1, and I'm just extending this towards x-axis. So this distance will be x2. Therefore, what will be the distance, horizontal distance from point P to Q? Let me show it. So the horizontal distance from point P to Q is x2 minus x1. Similarly, another perpendicular distance, let me draw it with the help of a straight line. So this distance, you can understand this as y2 minus y1. Now we got a right angle triangle, and this angle will be equal to 90 degrees. So this angle is 90 degrees. So this angle will be equal to 90 degrees. Now, according to, let me consider this point as O. Now, from triangle POQ, we know that according to Pythagoras theorem, we can write PQ square, which is the square of the hypotenuse, is equal to sum of the squares of the remaining two sides. So it is PO square plus QO square. Okay. Now what is PO? We can clearly observe it as x2 minus x1. And what is QO? It is y2 minus y1 whole square, and it is also square. Now PQ, which is the distance between the 2 points whose coordinates are x1 y1 and x2 y2, is simply under root x2 minus x1 whole square plus y2 minus y1 whole square. In this way, you can easily apply this formula to find the distance between any 2 points if you know their x and y coordinates. They are equally applicable for a three-dimensional system also.